Welcome to the AirCon Vault. Here you can find recordings of the live streams from AirWiggle's audio conference. These are made free thanks to our sponsors: A Sound Effect, Aftertouch Audio, Boom Library, FMod, Game Audio Learning, Game SoundCon, Kilohertz, Rev Rooms, Soundcuts, Strata from Audio Kinetic, and AirWiggles, the online home for audio people. We hope you enjoy the video.
Welcome to my talk called C++ for Audio Blueprinters. So first of all, really quick about me. My name is Horacio Valdivieso. I'm originally from Ecuador, from South America, and I'm based in the US. I'm a technical audio designer and gameplay audio programmer. I'm currently work for Hard Machine in Los Angeles. And I'm a Wwise and FMod specialist, especially in combination with Unreal Engine. And I've been a recording musician, a music producer, and composer in the past. I also been a music educator. I work as a music college instructor for like about 10 years. So I've been, in this wearing these many hats related to music and audio, and now in game audio and in tech. And I'm really excited about doing this because I'm very passionate about education and mentoring. And yeah, I love like teaching and sort of like, dividing complex problems in like, let's say digestible chunks of information that a beginner can understand. So I also would like to mention that I don't have a traditional computer science education. So most of the things that I'm going to share with you, I learned them by experience or just by self-study, research, and just by having to solve complex problems, right? So who is this talk for? I guess for anyone that is interested in game development and programming, right? But I'll say that the tech audio designers that are already working with blueprints and comfortable with blueprints will benefit a lot from this talk. Software engineers that are not necessarily game engineers, that maybe come from web development or other types of branches of software engineering that are, that want to learn about Unreal Engine and game development. Software engineers that work with us audio folk, right? And I think some of the game audio educators maybe will get some interesting ideas from this talk. So what are we going to talk about? What I want to share with you, right? So I'll start with sort of like explaining what is the relationship between blueprints, the blueprint visual scripting layer, and C++ and Unreal C++. I want to give you some tips on how to use the knowledge that you already have using blueprints to learn C++ in Unreal Engine. Then big chunk of my demonstration will focus on blueprint function libraries, and in kind of like in relationship with that, we are going to briefly open the Wwise and FMod blueprint statics, which are like the blueprint function libraries that are the part of the official integration of Wwise and FMod with Unreal Engine. And some techniques on how to expose C++ functions to blueprints. And last but not least, the blueprint implementable events. You will see what I think this is a super powerful tool especially for beginners in C++ in Unreal Engine, and some tips on how to go farther from here. So what would you want to learn Unreal Engine C++? Okay, I think when I say expressive, right? When I think about the word expressive in my head, it means having more vocabulary, right? Having just more words or more tools, right? And so if you have more tools, you'll just become a more free, let's say, audio professional, right? You'll be able to implement more things or know how to solve problems better, right? And video games are software. So sometimes we forget that no matter if you are a designer or sound designer or music composer, 3D modeler, writer, if you're working on a video game, you are developing software. So learning and knowing about software, right, will just make you a better contributor to your project, right? So don't forget that what we are doing, what we are making is a product that will run on a computer. So learning about how computers work and what are the sort of like the possibilities and limitations will just give you more tools, right? And a better understanding of how to creatively implement your audio in your games. So frame audio implementation problems more effectively, right? So this is kind of like redundant, I guess, from the previous point. Become a problem-solving machine, right? So when you have an access to code and you are not just constrained by I'll call it like the wall garden, right, of blueprints. You don't have any limitations on the bugs that you can solve, for instance, right? And then, I guess we all want to, level up and get like better positions, better salaries, and just more interesting, more interesting positions where we can solve more interesting problems, right? So, and one thing that I forgot to mention about the previous slide is that everything that I'm going to share with you is kind of like a way of convincing you, trying to convince you why. Okay, so if I'm good at blueprints already, if I'm solving most of the problems that I need to solve with that, why would I need to learn C++, right? And so keep that in mind, along my presentation, that is sort of like I want to give you some ideas on why would you like to learn about C++, right? And just deepen your knowledge into this tech. So how blueprints relate to C++ in Unreal Engine, right? What is the relationship between these two layers? So blueprint types are reflection of types in C++. So these first two examples, so I have two U assets from the Wwise integration, right? Wwise official integration, right? So I have an audio event and an RTPC, right? Assets that we use every day in our work. And here at the right, you can see, on the right, you can see that these are like the declaration of these types or of these assets in C++, right? So these ones need to exist so you can see these assets in the editor, right? So the next ones, I have two assets from the fmod integration. So an fmod event and an fmod bank. And you see here are the declarations of these types in C++. And last but not least, Unreal Engine Audio. I have a meta sound source and a sound submix here. And we can see the same examples here. So what I want to emphasize here is that all these assets that we use are, first of all, declared and defined in C++. Next slide. The blueprint types extend C++ types. So all the blueprints that you create and that you extend, well, right, in the editor are come from a parent, a common parent in C++. So for instance, in this case, I have a BP custom fmod audio component, which I extended from fmod audio component, which is already in C++. And that extends from or inherits from scene component, and that inherits from actor component, and that inherits finally from object, right? Which is kind of like the common parent of everything that we can use and manipulate in the editor. And on the right, I have a character, right? Many variations, kind of like specializing, specializations of my characters, but all of them inherit from character, which is C++ class from the engine, and that inherits from pawn, then from actor, and from object. So blueprints extend types in C++. And blueprint nodes are created in C++. So Wwise, for instance, set RTPC value, right? A common node that we call, for setting parameters. And you see that set RTPC value is declared and defined in C++. So UAK game object, set RTPC value. This is exactly the same. Fmod, set post, right? And that exists in the audio component, fmod audio component class. And from Unreal Engine Audio, in audio component, fade out, right? So these are exactly the same as these ones, right? Okay, so let's write some code. I'm going to do a live demonstration of because I want you to see, how we think, and I want you to see kind of like how I write the code, and then I compile it, and the code hopefully working. So let's go to so let's start with this blueprint function libraries. So I have 3 nodes here. I have one for Wwise, one for Fmod, one for Unreal Engine Audio. So post-event function that we call everyday, right? Or playing a sound, right? If I hover on top of it, right, I have hopefully some helpful documentation of what this function does. But I want you to focus on the second line. And if it's too small for you to read, it says target is AK gameplay statics. Okay? Target is AK gameplay statics. Good. So if I go to my IDE here, and I search for AK gameplay statics, right? Here is the class, AK gameplay statics. And notice this one, this line, this is the declaration of the class. At the right, it says that inherits from U blueprint function library. Okay, blueprint function library. And if I look for post event, here is the function. This is exactly the same function that that I have here, right? Okay, let's go to the fmod. I hover on top of it, and it says target is fmod blueprint statics. Now, I'm going to double click on this function, and my IDE is taking me there, and it says play event 2D from fmod blueprint statics. And if we go to the declaration of this class, fmod blueprint statics, you see that it inherits again from blueprint function library. Okay. Last, from Unreal Engine Audio, if I hover on top of it, it says target is gameplay statics. Gameplay statics. So let's go back and gameplay statics. It inherits again from blueprint function library. So most of these nodes, these blueprint nodes that we call every day, are actually functions that are declared and defined in a blueprint function library. So for instance, another ones that we commonly use here, like get player pawn, right? Target is gameplay statics, again, the same one as this one, right? Or get game state, right? So the same, target is gameplay statics. So, okay, why don't we create our own blueprint function library then, so we can start like playing with it? So the easiest way to implement a to add a blueprint function library or add any class, any C++ class in Unreal Engine is to use the editor itself. So we are going to click on Tools, New C++ class, and then I'm going to find blueprint function library. Okay. Next, I am going to put it in the source folder because it's a source, it's code. So it's in the source, it's a source file. Lyra again, because I'm using the Lyra template project. HLyra, which is the folder that I own, let's say. And I'm going to put it here. So select folder, and I'm going to call this air wiggles function. Oh, air wiggles function library. Okay. Create class. Nice. So my project is going to compile this addition to my code base now. Cool. So succeeded. Got it. So that why I suggest, especially at the beginning, to create a new C++ files or classes in the editor is because the editor will sort of like create some of the boilerplate code that Unreal Engine needs, like for instance, this generated body or this U class, which are like macros that the reflection system of Unreal Engine requires the code to have, right? And so you see that I have two files now. I have an airwiggles function library.h and an airwiggles function library.cpp, right? So this is how in C++ we sort of like separate between the definitions of data or functions and the declarations of that data. So I have a screenshot here of a blueprint graph, right? And so how would you kind of like make the connection between the H file and the CPP file with this? Is that this section right here, the one that has the components and my blueprint, and the one that has all of the variables and the name of the functions, this is the H file, the .h file, right? And the place where you're going to actually implement the functionality of your, of your methods, of your functions, right, is here in the graph, right, in the blueprint graph. So this will be comparable to the .cpp, right? So let's start writing actual real code. So let's explore the first case. Why would you like to write some? What would you like to learn and write some C++ code, right? And so for me, to extend or modify is kind of like the perfect excuse to learn this, right? So, and I'm gonna try to use one examples for each, for one for Wwise, one for Fmod, and also with Unreal Engine Audio. Okay, so I'm going to start with Fmod. So we have this function called setGlobalParameter which is part of the official Fmod and Unreal Engine integration, right? So let's go to my project. And so I implemented pistol fire sound, right? And so when I fire my pistol, when I'm outside this volume here, I expect to hear a long tail. When I'm inside, I expect to hear a shorter tail, right? And so let's listen. So I'm inside, outside. Okay, so hopefully it translates to you. And these sounds are implemented in Fmod, okay? And so how am I changing the tail from long to short? Is I'm setting a parameter. So if I drag this to my screen, this is the parameter editor in Fmod. I have a parameter name called outdoor state, and then I have a label called indoors and outdoors, and it has an array location, right, of 0 and 1. And this is implemented here in this gameplay queue notify called weapon pistol fire. Okay, so on burst play pistol fire, and so what is happening here is that I'm checking if the weapon is valid first. Then I'm asking the weapon, please give me your owner, which I expect to be my player character, right? And I'm asking for I'm asking the player to give me the actors that it's overlapping with, specifically a trigger box. So in this case, it's this trigger box, right, that I want to find. And for every trigger box that you found, please give me the tags that it has on the on its array. And if you find a tag called outdoor state, right, it means that we are indoors then, right? And so if we are indoors, right, give me set this global parameter by name, right? This is from the Fmod blueprint statics, and give me a value of 0 and 1. And in this case, this works fine because it's inside or outside. But I don't like this too much because it's sort of like, if I created this, well, I understand what it does. But if someone else reads this, what does it mean to be 0 or 1? Let's say you have like parameters with many labels, like materials, for instance, like a footstep system or a material impact system, right? Like what is 1, 2, 3, 4, 5, 6, 7? You don't know. I think it's more clear, more explicit if you say gravel, grass, ice, etc. Right? So I would like to input these values, indoors or outdoors. Unfortunately, the Fmod official integration of the engine doesn't expose a function from the Fmod engine that is called set global parameter by name with label, which allows me to do that. So if you use Unity before, for instance, in Unity, this is exposed, right? But well, I can fix that. I can sort of like expose that myself, writing some code. So let's kind of do that. And so first of all, I'm going to see what is the implementation of this function. So double click, and I have set global parameter by name here, right? So I'm going to copy the contents of this function, and I'm going to paste it here and just I don't know why this keeps changing from English to Spanish, but anyway, okay. So I'm going to comment this here, and I can close this. And so I'm going to write my function, right? And so these are static functions, and we don't have to really get deep into what is a static function, but it's just a function that will have one place in memory, and because of that, all your code base is able to find it, right? So Blueprint function library needs or implements static functions. So I need static, and then this is a void function because it doesn't return anything, right? And it's called set global parameter by name with label, right? And I need two inputs. I need an f name, a name, for the name, and I need another f name for the label, right? So this is the declaration of my function, and super important is I need this function to be exposed by Blueprint on the Blueprint layer now. So how do I do this? I write this macro called ufunction. And the only thing that I need here is to add a specifier that is called Blueprint callable. Okay, good. So this is the declaration of my function. And now in the CPP file, I need to implement this function. So I need to, it's auto-completing, but I want to write it myself for now to demonstrate. So void, right? I don't need to put a static anymore. First of all, I need the name of my class, which is AirWiggles function library, colon, and then set global parameter by name with label. And now, I know that for this, I'm going to need to sort of like tell my source file where to find the things that it needs. So I know that I have to implement or include the fmod studio module .h, and also I need to include the low-level header for fmod studio, which is fmodstudio.hpp. Okay. So now I'm going to copy this line that I sort of like copied from the official integration. So fmod studio, this is pretty much grabbing the audio engine, right? The pointer to the audio engine. And I'm going to say if you find it, right? Because I want to check if it's not valid. Otherwise, this might crash your engine, your project. So fmod studio, studio system, please set set parameter by name with label. That's the function. Okay, and I need to pass this, right? And I'll copy it again, but this will be the label, right? And that's it. That's the implementation of my function. And I'm exposing now this thing that I'm missing, right? From the official integration, right? So what I'm doing here is getting the fmod engine, right, here, and then calling this function called set parameter by name with label, right, and passing the name and the label. Good. So I'm going to recompile now. Oh. Let's see, let's try again. What am I missing here? Oh, okay, sorry. So I had a kind of like double quotation here in the fmodstudio.hpp. Nice. Cool. Now, so if I try to find set global parameter by name with label, here you can see that using the AirWiggles function library class, and now it looks like this. And the name is outdoor state. And what I can do is say select name. And so if it's indoors, please pass the indoors. And if it's outdoors, please pass this label. So to me, this is way more clear, right? This is better in terms of what am I trying to do now? Do now, right? So let's see if this works. So outside, inside, yeah, and if you don't believe me, we can put some breakpoints and actually verify that the process is getting there, right? So if you don't know how to put this, right? So you can say right click and put breakpoint or press F9, right? And so, okay, the process got there. And so we can verify, okay, yes, it's indoors, right? And if we go outside, outdoors, perfect. We can do the same in code. So if we go to rider again, I can put a breakpoint here and do the same. And it hit my breakpoint. And outdoor state is the name of the parameter, and the label is outdoors. And now the studio system, we found the studio system. This is the memory address of it, and we call the set parameter by name with label. So it works. Okay. Cool. So first example. I'm going to check the chat really quick to see if, okay, good. No one is complaining about no audio. Cool. So, okay, now let's go with Wise. I chose this execute action function. Okay, so I have a sound now here that is attached to this sort of like health pack. And I want it to be attached to this health pack because you will see that it has sort of like an animation that goes like oscillates like up and down, right? And so I want it to be attached to the sound, right? So because to me that's interesting. And so I'm hearing it while it's sort of like levitating on top of this pad. And as soon as the character sort of like collects it, right? Overlaps with it, it will disappear and the sound will stop. And then eventually it will respawn again, right? So let's try it. Okay, it stops, then we'll respawn. Cool. Okay, so this is implemented in, I think is in this class. Yeah. Okay. So when the game starts, right, very simple. When the game starts, I'm playing this loop, right? And so what I'm doing is I'm fetching a Wwise event from a data asset. So loop Wwise event is this one, right? If it finds it, then it's creating an audio component attached to the weapon mesh, right? Weapon mesh, right? Get or create a AK component, and then is posting this event, right? And finally, what I'm doing here is I'm caching the instance of the displaying event, right? And so if you don't know what is happening here, is that Wwise works like this, right? So you have game objects or AK game objects, and then you are sort of like injecting events into those, right? And then the audio engine sort of like gives you an unique identifier of this event, so you can further control it. You can stop it, you can pause it, right? And then when I am overlapping the so when I'm collecting the health pack in this case, I'm doing sort of like the reverse, right? I'm getting the component that I created attached to the weapon mesh, excuse me, and then I am stopping it. So this is good and works fine, but the problem that I have with this is that this is stopping the game object itself. So it's sort of like stopping without any fade, without any any curve, any envelope, nothing. It's just stopping, right? And I want to stop it with a nice curve. Okay, and so in the latest Wwise integrations with Unreal Engine, the only way of doing this, right, is by calling execute action, and it's a function that has it's kind of like a big abstraction. So it has a lot of things that you can pass. First of all, you need to pass an audio event. So it means that I have to sort of like get my audio event, the same audio event that I played on this component, and then I need an actor, and if you read, it says executes action on the different playing IDs from this event that were previously posted on the actor's root component. And remember that I attach my AK component to the weapon mesh. This is not the root component, right? This collision volume is the root component. So, and I kind of like miss kind of like the functions that were exposed before in previous versions, right? Especially one that is called execute action on playing ID, right? And so because I don't like this, I'm going to fix it myself. So let's go back again. And so kind of like to save some time, I'm going to copy some of the functions that I have like prepared already. So I'm calling this execute action on playing ID, right? And I know that I need to include the AK gameplay types which is a file that has all of the definitions of this AK action on event type or AK curve interpolation, which are just enumerations. And so I'm going to implement this now in my CPP file. And I know that I'm going to need include Wwise, I think API, and Wwise Sound Engine API. This is the interface between Unreal Engine and the low-level Wwise audio engine, right? So I'm going to need that. And the first thing that I want to verify is if the playing ID that I'm passing is less or equal than 0, it means that it's invalid. So I passed something wrong, right? So I can't do much with that. So I can, I just return the function. I want to stop the process there, right? And just keep going with the rest. So and I'm going to log kind of like an error here, UE log, and this is the category will be like log audio. You can create your own categories, but we're not going to do it now. Warning as the severity, and then text, playing ID not valid. Okay, return. If it's more than 0, then I would assume is a valid instance ID, right? And so I'm going to copy this here. So I'm getting the Wwise audio engine, right? Wwise sound engine get sound engine, and then I'm calling execute action on playing ID, right? And so you can go into the AK gameplay statics and see this exact sort of like implementation, right? And so you can make sense of it. I'm pretty much changing the type, this action type, which is called AK action on event type, to something that Wwise, the enumeration that the Wwise engine understands, right? So that's why I'm casting this there. The same with the A curve interpolation, right? Because this is EAK curve interpolation, which is sort of like a wrapper for Unreal Engine. And so the Wwise engine needs AK curve interpolation. Anyway, so let's compile and see what happens. Nice. Okay. Okay, good. And so now I can call execute, execute action on playing ID. So we had this before, but now that's not here anymore. So I'm sort of like bringing it back, right? Because I need it, or I prefer to work like this. So so now I can pass the loop audio instance ID with which I cached before. Remember here when I play the event, and I want to stop the event, and let's exaggerate it a little bit. So I want to have like a fade out curve of 3000 milliseconds. Okay. So let's see if this works. So it's playing and it's fading out, right? Too long. I mean, I wouldn't implement something like this, but just to make my point, right? And so again, let's put a breakpoint here. And it hits the breakpoint. Perfect. And again, let's go to the code, to the CPP file, and let's put a breakpoint there. And so it hits my breakpoint. So playing ID is 10, which is valid, right? Or hopefully it's valid. It's grabbing the sound engine pointer, a pointer to the sound engine, which is valid, see, and then calling execute action on playing ID. Perfect. So, okay, that was wise. And for the next case, I'm going to, I think, okay, so when you want abstractions, what do I mean with this is when you notice that you want a lot, kind of like the same combination of functions, or yeah, the same functionality, sort of like together, and you don't want to rewrite it every time, right? And so you abstract things that you want as a whole, right? And you sort of like encapsulate them. In this case, I'm going to do it with a function, right? So I'm going to use Unreal Engine audio for this. So spawn sound 2D, I'm going to use that function, or create sound 2D, I'm going to use it specifically. So now let's go here. So I have these two platforms. These two platforms, when I step on them, I'll hear some sort of like UI sound. One will be positive and one will be negative. And so, but both are using the same source. So this meta sound source, which is called UI gameplay effect path. Okay. And so it's the same sound in both, but if you pass this parameter, sound type, value 1, it will be positive, like that. If you pass 0, it will be negative. Okay. So, good. These are implemented in this thing. Let me see. Yes, heal. And damage taken. So these are gameplay queue notifies. And this is like a special gameplay ability system that the Lyra project uses. So very modular, kind of complicated, but yeah, that's what it is. Super powerful too, but kind of complicated. And so I have this function here, play sound 2D with parameter float, which I created in Blueprints, and it's here in this class. But you notice that if I go to the other class, I also sort of like re-implement this function here. So I'm sort of like repeating myself. And let's say that in my game, I sort of like the architecture of my game is that every time that I want to play a sound, I'm also, or most times, I'm going to pass as well a parameter. So, so this is the implementation of this function. And so I'll have to rewrite every time that I want the same functionality. I want to rewrite sort of like the same nodes, the same process again, right? So what I'm doing here is I'm validating the sound asset, right? So if I'm not passing any null or empty, then I'm creating an audio component. This is from Unreal Engine, remember? And passing a sound to it, then setting a parameter, right? Playing the event, and then returning the audio component that I created. And if I open the other class, you see that I have the same implementation here. So I have to rewrite everything, right? Drag the nodes and paste, so. And okay, so I want to sort of like create like a function that encapsulates or abstracts all of these nodes into a single call, because I know I want to call it in many places, and I don't want to rewrite this, right? And I could just keep it in Blueprints. That's fine. But because I'm learning C++, I want to write this in C++. And also, this gives us the benefit that programmers will be able to call this function as well from code, right? because you can't really, it's not easy to call something that implemented in blueprints from code, right? It's kind of like the communication is just upstream, right? So cool. So third function. So I know that I'm going to need this. So this is my function, play sound 2D with parameter float. I'm pretty much sort of like rewriting. I'm going to rewrite what I have implemented in Blueprint in code. Okay, so cool. So this is the declaration. Now I'm going to define the function, and I know that I'm going to need include components, audio component. Thank you, writer. Include KISS math and gameplay statics. Okay, first thing I need to do is verify if the world context object, and I'm going to explain what this is in a moment, is valid. And I also want to verify that the sound that I'm passing is valid, because I can do anything without both, right? So if any of these fail, well, I can do anything. So I'm going to return null pointer, because I promised to return an audio component, right? And so because I can't, I have to return nothing. So good. Now I need the gameplay statics create sound 2D, right? And I need to pass the world context object, and I need to pass the sound. Those are the two things that I need, right? This returns a audio component, right? Audio component, like that. So I need to now set the parameter audio component, set float parameter. Yep. So parameter name and parameter value, right? And finally, well, not finally, but audio component play, so we can hear the sound, and then finally return the audio component, right? So this is exactly the exact thing that I had here, the exact thing, but rewritten in C++. Okay. And so just a note on the world context object. So a lot of functions in Unreal Engine need this world context object. So this is very tied to the Unreal Engine netcode, like the multiplayer sort of like modules of Unreal Engine, right? And so it's a way of functions, or is a way of the systems to identify in which world we are at now. So really quick, if I open the create sound 2D function, and I show you how that looks, right? So what is happening here is that this function wants to know if, first of all, this world exists, right? And if it allows playback, and especially it wants to know that it is a dedicated server, right? I mean, like a headless computer, right? So you don't need to listen, you don't need to hear any sound here. So this is a way of verifying if this where this object is living on, and so if it passes the validations, so it actually, in this case, play the sound, right? So that's why you need a world context object, and you will see this pattern in many places in the engine. Okay, so I have my function, play sound 2D with parameter float. I'm going to compile. Let's see if it doesn't fail. Okay, good. So let's see. Play sound 2D with parameter float from the AirWiggles function library. Cool. So I want to disconnect this one, which is in Blueprint, and passing the parameter name sound type and the parameter value 0, which is negative in this case. And I need my meta sound, which is UI gameplay effect pad, and the world context object, it can be just, you know, a reference to the self. Let's see if this succeeds. Or it can be anything else. It can be this character, or it can be this mesh. It's just like any object that can tell the engine which is the world that we are calling this from, right? And I'm going to do the same in the healing path. So disconnect this here, play sound 2D with parameter float, and pass 1 instead of 0, which is positive, right? So let's see if this works. Positive, negative. Cool. And let's put a breakpoint just to verify that this is actually working. So breakpoint there. Aha, that was weird. So yeah, it's hitting the function. So world context object is the gameplay cue notify, damage taken, right? Sound is the UI gameplay effect on path, on interact, parameter name, sound type, parameter value 0, right? And so this will verify these are valid. So create the audio component. Oh, weird that it's not showing me the address anyway, but yeah, okay, yeah, here it is. So this is the memory address of the audio component that we created, set parameter float, and play, and perfect. Whew, that was a lot, right? So okay, so this was like an idea, right, of creating abstractions, kind of like why would I like to write C++, right? To create abstractions that can be accessed to from Blueprint and from C++, right? To not repeat myself, right? And the last but not least is this case, declared in C++ and defined in Blueprint. So, you know, this is very powerful because especially if you're beginning, right, with this. What if you are not really comfortable yet writing a lot of code, implementing things in code, but you want to sort of like be able to define something in C++, but implement the functionality in Blueprint, right? Because maybe you want to still iterate, you still want to experiment with things, right? So I'm going to implement this in my player character. I don't necessarily encourage to implement this audio directly into the player character because that wouldn't be kind of like nice for maintainability, but just to make it easier for us, right? So BP hero shooter mannequin inherits from BP hero default, and hero default inherits from H character default, and H character default inherits from H Lyra character, and this is in code. So H Lyra character. Okay, so I'm going to create a function here called play on defeated audio. And so this is outside the topic of Blueprint, the Blueprint function libraries, right? So this is not a static function. It's a function that is a member function that requires the object of this character, right? So it's play on defeated audio. And what I want is, let's say I'm talking to a programmer and telling him or her, I want like a function that is triggered every time the player dies, the player is defeated. And then I want to sort of like implement whatever cosmetics audio myself, because I'm not really sure what I want yet. But I want to have this function that reliably is called when the player gets defeated. And but I want to know if it fell out of the world and that's why it died, right? Or that's why it's defeated. And so I'm going to write this myself just for you to see. So the important thing now is the ufunction macro. Now we'll have a specifier called blueprint implementable event. So I'm telling the Unreal reflection system that I don't want to implement this in C++. I want to do it in Blueprint. I just want to declare the signature of the function. So I don't need to implement the function in C++. And then on this function, on get started, which is part of the character, I'm going to call this play on defeated audio. I'm just going to pass fell out of world internal, which is sort of like the Boolean that is tracking if the player fell out of the world. Okay? Okay. That's it. Recompile. Okay. So where is my character? I think it's this one. Yes. So I already have like the implementation here, right? The only thing that I have to call now is that function which was called that event, which was called play on defeated audio, right? And so what is happening here is if the player got defeated, but it was anything but fell out of the world, right? Then I'm going to handle all of the cases here, like grenade, it died because of a melee attack, basic attack, whatever. But if it fell out of the world, I want to play a sound, right? Again, this is not my favorite way of implementing. I will use like some data assets or move this to an audio component, etc. But just to make it simple, right? So if it falls out of the world, I want to play this stinker defeated fell out of the world sound. Okay. So I have this. So I have that, and so I'm going to quickly. Where is it? Shooter mannequin. I'm going to put a breakpoint there, and play again. And it hits my breakpoint, and it fell out of the world. So please play this stinger, right? Okay, so that's the kind of like last example that I wanted to share. And so, wow, the game, the engine didn't crash. So I'm impressed. So, okay, to finalize, last points here is let's have a quick comparison between blueprints and C++. And what would you like to implement things in the blueprint layer or in C++? Kind of like the engine, different teams work in different ways, and sort of like set the separation of these layers, in at different points, right? So what would you like to do it, right? And I guess with the experience, you will sort of like get a better understanding and make a better decision on where you start using blueprints, and what are the things that should be written in C++, right? So blueprints, they don't need recompilation. Changes are immediate. And C++, you have to recompile. So you see that I wrote some lines of code, and then I had to wait for the recompilation. The engine is better now about doing that, but you just have to wait, right? Because that module needs to be recompiled. So blueprints are binary files that can only be interpreted by the editor. So they can't be merged. That's why we use, centralized version control systems like Perforce, right? So one person, one developer can only work on a binary file like a blueprint at a time, right? In contrast, you can see many programmers sort of like writing on the same source file at the same time, and because it can be merged. It's just text, right? So that reduces conflicts. Blueprints, you require only the editor. You download your Unreal Engine and you have your project, and then you open it, and that's it, right? C++, it requires a development environment. It requires, the compiler, the tool chain, Visual Studio, Rider, Xcode. So it's a more involved way of working. Blueprints is just user-friendly, right? Graphic user interface. So you drag nodes, you connect them together. It's sort of like clear what is happening there, right? And it's pretty much you can't really make a mistake, right? So in C++, it has a very strict syntax. You have to learn the syntax, right? So if it's not correctly written, like what it happened to me in the first example, right? If it's not correctly written, the program will just not compile. With blueprints, you just have a narrow access to what is exposed to you, right? This kind of like walled garden, right? And so you just can see what is exposed there, right? With C++, you have access to everything, all the source code of the engine, all the source code of the third-party libraries, middleware like Wise, Fmod, everything. So you can, you can just have access to all of it. Blueprints may cause performance issues, and this is kind of like a very sort of like contested or complicated conversation. Kind of like the performance is sometimes is kind of like negligible, but what I want to talk about is that blueprints can cause especially loading issues, right? Because especially if you are casting to classes that have a lot of content already, you may cause this chain of dependencies that end up increasing loading times. That's it. And C++, well, you may crash the game of the editor. A common crash is because a pointer is null. So you are passing something that was expected to be filled by a type, and this memory address is null. So blueprints are suited for assets and cosmetic operations. I can just replace one sound for another sound. I can just replace one mesh to another mesh, see the changes, really quick. C++, again, it needs to be recompiled. So it's more about efficiency in terms of kind of like processing power and efficiency in general for the hardware. So it's more suited for core systems and data. And this is very important. So let me know please let me know if someone knows about this. But blueprints you can't really debug you can put breakpoints and connect to a package build, right? And see your process like stopping there. But you can do that with C++. So you can connect to the process and just put a breakpoint and debug package builds, right? So going further, read and write lots of code. Always make a package build. Ask for feedback, find a mentor. This is important. Ask your technical director, hey, I want to write code and I want to be part of the engineering stand-ups. Ask for feedback, right? I mean, the things that I know and my experience is because I've been able to work with very generous engineering teams that, have taught me a lot. So ask for feedback, find a mentor. And maybe forget about audio for a bit. And if you are really interested in game audio programming, you will realize that a lot of game audio programming is gameplay audio programming, right? Most of the work that you're going to do. So learn how the engine works, the gameplay framework of Unreal Engine. What is a game instance? What is a game state? What is a player controller? How does it work? Etc. So maybe forget a little bit about audio for a bit and just learn gameplay programming. Ooh, and so that's it. Thank you. So I'm gonna now check the QA to see if folks have any questions. Okay, let's go from the top. So Nikhil asked, are soft class object references like pointers? I'm always confused between objects in C++, OOP, and the object class within Unreal Engine. So a soft class, so a soft pointer or a soft object or a soft class is a sort of like an address to the asset itself, right? In the editor. So it's not guaranteed that the object is loaded into memory, right? So that is nice when, for instance, you know that you will need something, but you don't want to load it from the beginning, right? And so what you need to do is say, okay, if it's, please give me, I have this soft class or soft object, and I know where it exists in the project, in the package build, and I'm going to attempt loading it if it's not loaded already, right? So, and also it sort of like, it's part of also, how do I say this? When you have like a reference to a soft object or class, you are saying that the object that holds that object is not the owner, right? So the garbage collection system can delete it, right? And so you have to check if it's valid. Okay, in your opinion, from Oberon, in your opinion, what are some of the biggest challenges or roadblocks new technical sound designers or audio programmers face when trying to learn these techniques and implementations? I think is I think a lot of this knowledge and a lot of like kind of like knowledge about game audio or game development in general is sort of like, to me, feels like a secret club. So kind of like you learn this because you have to get a job first to learn this, right? So there's not like a web page or a course or something that will tell you this is exactly how we work and how do you develop games in Unreal Engine, for instance. There are a lot of material, but you have to sort of like filter out yourself. But I guess to me that's kind of like the biggest roadblock. And I don't think, for instance, game audio professionals that have a lot of experience don't want to share is. It's just, I don't know what it is. It's just, I don't think it's shared enough. I don't think a studio sort of like shares their pipelines and stuff like that. So so yeah, and that's why I'm doing this, and that's why I guess AirWiggles exists, right? Voter Meyer, sorry if I don't pronounce your name correctly. Are there performance reasons why you should do things in blueprints versus C++? Why you should do things in blueprint versus C++? Instead of, to clarify. Okay. So blueprints have a small overhead that can compound if you are doing really taxing operations, like very hard, like heavy math, or things that are happening on tick or on update, like on every frame, right? So you should be careful with that, or things that are like double nested loops. Don't do double nested loops, like doubly nested loops in blueprints. Find a better way. But if you are doing very straightforward things like calling an event, right? Calling a play an event and things like that, it's just, you should do it like that because it's easier even to iterate and change parameters and variables and stuff like that. So, but again, you'll sort of like get a better sense of this with experience. Guido, when modifying a header and compiling, it often happens that Unreal forgets or misses some previously established components or variables or variable values in a BP. Do you have some recommendations for avoiding that? It often happens that Unreal forgets or misses some previously established components or variable. Interesting. I'm not sure. We should talk about this later on. I mean, to really understand what is your problem here. So, Matisse, when you add functions through C++, does it create BPs as well? In the sense that when you create BPs, it adds the functionality as code in the C++ files. Does it do it in reverse too? Okay, so what I'm understanding from your question is, if I add a coding, function, let's say in C++, so it doesn't create like a blueprint, like a blueprint class, but what it's doing is creating a function that you can call in C++ and also in blueprints, right? What is not possible is if you create something in blueprints, in the blueprint layer, and then expecting to call that from C++. That's sort of like the limitation, right? So sort of like the communication is just upstream. You said that uFunction is a macro. Could you explain what a macro is? A macro is sort of like a way of, again, encapsulating a lot of code. So when you put uFunction, when you write uFunction, that uFunction, right, it takes just one line, right? But that is referencing like an implementation of a lot of code inside. So a macro is sort of like, when you have a macro on a synthesizer, right? So you are sort of like pressing one button, and that button is triggering many things that are like separated modules, right? And so a macro is something that encapsulates a lot of functionality in C++. Which IDE you prefer? Are there situations you switch between IDE as well from Butter? I prefer Rider because Rider has like a amazing integration with Unreal Engine, right? You see that I could just double click on a blueprint node and it will take me immediately to the source file, right? And so also you can see kind of like, okay, which variables are being used in C++ and which variables are used in Blueprint. So I mean, it's great. It's super fast. In my opinion, I think Visual Studio it's very slow. In my opinion, it doesn't feel like as snappy, and so I sort of like learned a lot with Rider. So I would prefer Rider. The thing about Rider is that it's a paid, you don't have like a community version like Visual Studio has. So I know that you can ask for like an academic license or a indie developer license, but I am glad to pay the license. I mean, it's great. So okay, any other questions? So Rider takes you into a coding, right? Sure. Uh, okay, no more questions. So got it. So I think hopefully this was interesting to you and maybe motivates you, or gives you sort of like a that final push to dig into Unreal C++. And yeah, you can contact me anytime for anything, whether it's by my social media or through AirWiggles. And I'm always down for jumping on a call and answering questions or whatever. So yeah, thank you everyone. Bye.